Algebra 1, Investigation 7. In this investigation, we are looking at both direct and inverse variation. We have looked at these individually in other lessons, but today we're going to compare them. So many situations involve direct or inverse variation. The formula d equals RT, which relates distance, speed, and time, can represent either direct or inverse variation, depending on the variable that is held constant. A direct variation is a relationship between two variables whose ratio is constant. We give it the equation y equals kx, where k is a constant, it's not zero, called our constant of variation. It shows direct variation between our two variables x and y. When we talk about being held constant, what we are saying is if we were to replace one of the variables with a number, a constant, for in their example, if our rate is 55, like 55 miles per hour, in this equation here, d equals 55t, we would consider this direct variation. If we were to switch it and say something like our distance is 100 and we don't know our rate and time, in this case we have actually just created inverse variation. So depending on which one we actually put as our constant, we can have both direct and inverse variation depending on the situation. Let's go back to direct variation only. Identify the constant of variation given that y varies directly with x, so we know this is direct variation, then write our equation. So y is 10 when x is 2. Well, going back to what we know about direct variation, if I have this equation y equals kx, I need to figure out what is k, and then I can create my equation. Well, we have enough information here about y and x in order to figure out what it is. So if I plug in what I know, 10 equals k times 2, and I solve for k by dividing by 2 on each side, we see that k is 5, meaning that I can create an actual equation here by replacing k with 5 by saying, you know what, this direct variation is y equals 5x. All right, so in this case we would say constant of variation is 5, our equation is y equals 5x. So same thing over here, we're going to say y is 3 and x is 6, and we divide, and we see that k is 1/2 or 0.5, which means that our equation y equals 1/2 x. All right, and then we can look at a situation. The equation of direct variation can be written equivalently as y divided by x equals k. That's actually exactly what we did in both of these scenarios. We took y and divided by x in each one in order to find k. So that's a great way to remember how to find your constant, y divided by x. Alex walks 3 miles per hour. If he walks at that rate for twice as long, he will travel twice as far. The ratio of the distance and time is always the same. So let's answer some questions about this situation. Number 3, identify the constant of variation. Well, if we go back up here, it says Alex walks at 3 miles per hour. It doesn't say that he changes his speed, so that must be our constant. Our constant, k, is 3 miles per hour. So our speed, our rate, is 3. Write an equation of direct variation that relates Alex's time to his distance traveled. Well, that comes from our equation distance equals rate times time, and I've just figured out that my rate is 3, meaning that my equation is d equals 3t, or if you used x and y, we would use y equals 3x. Y representing the distance, x representing the time. Okay, so that's direct variation. As one increases, so does the other. With inverse variation, it's a little bit different. As x increases, y decreases. So they're opposite. As one increases, the other decreases. An inverse variation describes a relationship between two variables whose product is a constant, rather than the ratio being a constant. With direct variation, we said that the ratio of y over x is constant. With inverse, we say that the product, x times y, is constant. So it defines an inverse variation when we have this relationship here. So identify the constant of variation and write the equation for this inverse variation. Our equation is going to be in this form of y equals k divided by x. That's actually our true inverse variation equation. So I can though find our constant k by doing y times x. So in this case 1 times 3 is k, so k is 3. And we can plug it into our equation to say our inverse equation is going to be y equals 3 divided by x. On our next one, x times y equals k. So I plug in that I have y as 4 and x as 1/2, meaning that k is going to be 2. So our equation is y equals 2 over x. Notice the difference between our equations for inverse and direct variation. So when we have inverse variation, so here is our constant, how we get our constant. All right, just making like a little table here. And we have our equation. So direct variation uses a ratio to find k, but in the equation uses the product of k and our variable. In inverse, we use the product to find k, but uses a ratio of k over x in our equation. It's just kind of opposite each other each time. So let's look at a situation, decide if we have inverse or direct variation. So Alex lives 4 miles from the school. If he walks at a slower rate than normal, it will take him longer to reach his destination. In other words, the more time he spends walking home, the slower he is actually walking. The situation represents inverse variation. So identify the constant. Well, his house is not going to move. He lives 4 miles from home. Our distance is constant. Write an equation of inverse variation that relates Alex's time to his rate of speed. Well, our original equation, distance equals rate times time. If I replace 4 with my distance, I have inverse variation. And if I want to show it in another way, maybe solving for t or for r, I could say this is t equals 4 over r, or r equals 4 over t. Either way. But really, truly, we just have inverse variation because that product of r and t stays the same. Okay, so we're going to graph a few things here and complete this table. So first of all, we're going to graph y equals 3x and y equals 1 over x. Let's start with that y equals 3x. And from what we know about graphing our equations, we know that y equals 3x has an y-intercept of 0 and a slope of 3. So I'm going to go up 3 and over 1, up 3 and over 1, up 3 and over 1. So we have this constant as our slope. We see a straight line, it goes through the origin. And then so that's our y equals 3x. And then we have our other one, y equals 1 over x. For this one, what I'm going to do is I'm just going to plug in some different numbers for x to find y so I can plot them. Let's say that I plug in -3, -2, -1, 0, 1, 2, and 3. So when I plug these in, I'm going to get y equals 1 over -3, so we get -1/3. Plug in -2 and I get -1/2. Plug in -1 and I just get -1. Plug in 0 and I get 1 over 0, which is undefined. Okay, so when we do this, we're going to have that, remember that line that is an asymptote on x being 0, where it's undefined. All right, and then continuing on, plug in 1, we get 1, 1/2, 1/3. So that when I go to graph this, it's going to look something like this. -3 goes to 1/3, -2 goes to 1/2, -1 goes to 1. Okay, and hopefully we can start to see a little bit of a curve here. So what it's actually going to look like if I were to go even further is a line that curves down here and gets closer and closer to this x-intercept. Let's try that again. Okay, so we have this curve here that starts to get closer and closer to both the y and the x-intercept. Oops, I flipped it around. Sorry about that. Let me try again. Okay, we get y equals -3, -1/3, -1/2, and 1, here's our curve there, that looks better. And then we have the same over here, 1, 1, 1/2, 1/3, and we get this curve. Okay, so when you do this, this is what you should get, and on a graphing calculator, you'll see these curves and lines even better. So when we go back to our table here to describe some of these, is y equals 3x direct or inverse variation? Well, that straight line is direct variation, and we know that it follows our pattern of y equals kx. Is it linear or nonlinear? Though this is linear. Okay. Does it have an x-intercept? Yes. We have it at 0, 0. Okay. And then we have y equals 1 over x. Well, when I do this, 1 over x, we have inverse variation with those curves, so it's non-linear. And do we have an x-intercept? No, that's actually one of those lines that we cannot touch. We have that asymptote right here that's going to get closer and closer to, and our other asymptote, the y-axis, where x equals 0. Okay, so what are the differences between the graph of a direct variation and inverse? Well, the big thing is what they look like. Direct has a constant slope, it's a straight line, goes through the origin, whereas inverse variation, 2 curves that have asymptotes, so it's not even a continuous function truly. Okay? All right, number 12. Make a graph to determine whether the data show variation. If so, figure out what type of variation it is and write our equation. So the table shows force in newtons needed to move a rock, distance d in meters along the ground. So if I have distance 1, 2, 3, 4, and 5, we have a force of 600, 300, 200, 150, 120. The first thing I notice is that as I increase my distance, my force decreases here. So that already gives me a clue of what type of variation we have. But let's go ahead and graph this. So I'm going to really just be using this positive side of it, and I'm going to go up by basically 100s here. So here's 100, 200, 300, 400, 500, and then we'll say up here is about 600. Okay, and this is just a quick graph of what this is going to look like. At distance 1, we are at that 600 mark, so we have it right here. And at distance 2, we have it at 300. 2 is at 300. Distance 3 is at 200. All right, so this is our force. This is our distance. In here, we're just going by ones. All right, and then distance 4, we're going 150. And lastly, distance 5 was at 120. So we can start to see that this is definitely not constant. We don't have the same jumps between our distances as we increase. So we see this curve that is happening with our data. So is this inverse or direct variation? This is definitely inverse variation. What is the equation? Well, that comes from multiplying y times x. That'll give us our constant. Well, in each of these, 1 times 600, 2 times 300, 3 times 200, 4 times 150, 5 times 120, we get a constant of 600, meaning that our equation is going to be y equals 600 over x. Okay, last one, number 13. The table shows an employee's pay, P, per number of hours worked, K. All right, so I see 1, 2, 3, 4, 5 hours, and then we have 850, 17, 2550, 34, 4250. So as I increase the number of hours worked, my pay increases. Once again, gives me a clue of what this might be. As one increases, so does the other. Kind of sounds like direct variation. Let's graph it though to see what it looks like. If it's direct, then it should look like a straight line going through the origin. Well, does it make sense for it to go through the origin? 0 hours work does make sense that we would get 0 hours pay. All right, so with this, I'm going to make another table right here in this bottom bottom left-hand corner here. All right, and when we do this, I am going to go by, let's say, tens. Okay, so for 1 hour worked, it says up here that we get $8.50. So for that 1 hour worked, we have $8.50, right about there. 2 hours worked is going to be at 17. 3 hours worked, we are at $25.50, so about right there. 4 hours worked, we're at $34 exactly. And $42.50 for our last hour worked, so we're about there. So we see this very nice straight line that would definitely go through the origin. And so we say, yes, this is direct variation. And in order to find that constant, I need to do y divided by x. Well, in each of these cases, I have 850 divided by 1, 17 divided by 2, 2550 over 3, and so on and so forth. It ends up that that constant comes out to be 850, meaning that my equation that I can write is y equals 850x. All right. And that is all that I have for this investigation. There are a few investigation practice problems that you can try to compare and continually know how to identify both inverse and direct variation. I hope this helps with your homework and for studying.